It's July 15th, 2012. I'm getting ready to perform some testing on the Duality Lathe, particularly feed and speed testing. I got a production part that I need to run, and I figured I better have a good sense of what my feeds and speeds need to be in order to make this happen the way I want it to happen. So what you're looking at is a previously turned bar of aluminum that's 5/8 of an inch in diameter, 0.625. The tool that I have in there is a CCMT insert, not necessarily specific for aluminum, but it is something that works reasonably well. One thing I do need to do is start purchasing aluminum specific inserts, but we got to get some progress going with the machine first. So the speed and feed testing, the goal is to see what sort of roughing speeds I need at given diameters. The depth of cut I'm going to leave alone in this case, so we're running at 0.010 depth of cut. I wanted to keep it so that it's not getting into the end of the tool radius. The tool nose radius on this is 0.1565, so it's a what was that, 64th. I wanted to stay away from the back side of the tool nose radius. I wanted to stay down on the tip of it, keep the power requirements to a minimum. I'll probably test that later to see if I can push my luck. The goal is not to stall the machine or knock the tool post out of alignment, because that's pretty detrimental for accuracy. So right now I'm going to be checking roughing feed rates. I have it set at a single pass with the 10 thousandths depth of cut. Single pass will be at 3.5 inches per minute. I'll be running at 1,000 RPM, which is up toward the upper limit of the low range on this, so I keep the torque in a maximum. So I guess that's about it. I might as well start the run to see what happens. About 3.5 inches a minute, 1,000 RPM, 10 thousandths depth of cut. Material is 6061 aluminum. It's probably T6. That is the outside pass. It's indicating 3.4 inches per minute right now. I think I'll shorten that up so it doesn't have to run that full inch. No reason to remove all that material. But there's the surface finish. It's very nice, very clean. So I think I'm way short on where I need to be as far as roughing feed rate. You can see some striations on there if it's not completely out of focus, but definitely not down in the roughing range. So I'll try another pass. Alright, going to be running 1,000 RPM. Depth of cut is 0.010, so 10 thousandths. The feed is going to be 4 inches per minute on this run. The first pass at the outside diameter. This is the first real cut. Alright, definitely some more striations on the finish. Might be some chatter in there, but that's okay. I think it's alright. Get a better shot of this here. It's always difficult to get this camera to focus. Hopefully that should do it. Speed is 1,000 RPM. Depth of cut 10 thousandths. Width of cut, sorry. My brain is working in milling mode. The speed is 4 inches per minute. So that's 4.5 inches per minute. It's way too close. No way can you get a good view, but anyway, the surface finish is still okay. Didn't look like I was straining the machine any. Alright, this is 1,000 RPM. The turning diameter is 0.585 down to 0.565, so depth of cut of 10 thousandths. The speed is going to be 5 inches per minute, and the width of cut, or the total pass length, is 375. Alright, there's definitely some waviness in the material there. Nothing that a finished pass can't clean up though. And I have a task to do. Alright, we're trying something a little bit different on this pass. We've got a feed rate of 2 inches per minute, and we have a depth of cut of 25 thousandths. So I've increased the depth of cut by 2.5 times. 2.5 times the previous number, and I've lowered the feed rate back to the feed rate I have been using as my default, which is 2 inches per minute. So because of the steps that are already in there, I'm going to full length here. Because of the steps that are in there, it will progressively pick up material as it goes through. 2 passes. The first pass is going to be the full depth of cut. The second pass will be partial because the total depth of cut is not a multiple of the actual depth of cut. So that's it. Let's give it a shot. No contact so far, but it's getting close. Alright, here we go. Do the easy step first, and then the second step will be a little harder. And there it is. Oh! Nope, missing entirely. Apparently there's going to be a first pass that doesn't make much contact. This may not work out well at all. Oh yeah, we'll get full depth of cut on this pass. You get an idea. Extremely thin pass right there. 1,000 or 2. Not bad, not heavy at all. And here's a big cut. Of course, the finish on the material is good. It's about what I've been expecting. A little bit more heat, but the depth of cut is pretty substantial. Since it's 25 thousandths compared to what I'm used to, of course. Not substantial to anything real, but these small numbers. Alright, this is going to be the same parameters as before. 1,000 RPM. Feed rate of 2 inches per minute. The only real difference is that the depth of cut has been increased to 30 thousandths. That's a radial depth of cut. Skimming as expected. Tiniest little bits coming off. Probably related to material deflection at this point. There's a 30,000 pass. Alright, we're down under ½ inch on the diameter now, so I'm going to move on to larger material so that I don't spend too much time trying to learn this size when I don't spend too much time cutting this size. That's it. Alright, I've moved up to 1 inch bar stock. I'm presently doing basically the same thing I did on the last trip around. I have a feed rate of 2 inches per minute. Spindle speed of 1,000 RPM, and a depth of cut of 25,000. This is sort of the wake-up cut. Let's see how it goes here. No contact on the first pass, which isn't surprising since this is a fresh piece of material. Pretty good contact here, though. That's a significant cut right there. Definitely. Let's take a look. There's some material that's built up around the edge, a pretty significant burr, which isn't terribly surprising, I guess. The cutter is not perfect for it, but you can see that in addition to that, there's a pretty significant surface finish roughness there. So that is definitely too deep and too fast for this material, at least given the cutting insert. So it's definitely worth some review. I'm going to try now playing with my feed, increasing that, but lowering my depth of cut back to the minimum. Here we go. Alright, we have a depth of cut of 10 thousandths, a diameter of about 0.975 or so, and the feed rate of 3 inches per minute on this pass. Slight contact in the first pass, like usual. Alright, surface finish is notably better than it was last time. That depth of cut seems to make quite a difference. The surface finish looks pretty good. Time to up that a little bit. I think I'll stick with that depth of cut though. In fact, I may change my cut length a little bit to get rid of some of this crud from the last time. That's it. Alright, the same 10 thousandths depth of cut. The feed rate went up to 4 inches per minute, and all of the parameters are the same. Slight cut on the first pass. Apparently I didn't go far enough to get that burr off the end. The finish is about the same. That's it. And we're looking at the same 10 thousandths depth of cut with a feed rate of 5 inches per minute, spindle RPM 1000. Light cut on the first pass. Definitely a fast pass. Now the diameter of this is down about 1/10 of an inch from the original, we're getting down to 0.915. But see, there's a definite striation. Can't quite hear it, but there's a definite striation on the surface finish. See if I can back up and show it there. I think that's perfectly acceptable for roughing cut. We're definitely stepping it up here. I got 2.5 inch diameter piece of material. See, I can't even get it square in there because it's so short. And I'm about to run a pass on this. Alright, this is 2.5 inch diameter material, 6061 T6 651, I think. The depth of cut is 10 thousandths. The spindle speed is 500 RPM, and the feed rate is 2 inches per minute. Cut is still interrupted.